Oops. Got the sound on, don't I? Okay, let's see. I didn't put the section number. This is what? 4, 4. Right. So I'll write it now. So it's section 4, 4. So what I have here is I got a triangle. And watch, I'm going to purposely copy and paste it. So now what's true about these two triangles? They're congruent to each other. Now, if you remember from yesterday, in order for these triangles to be congruent, basically 6 things have to be true. We'll call this ABC and DEF. DEF. Okay? So if these two triangles were congruent to each other, you would probably, before today, you would have to show that angle A is equal to D. Talk to me now. Okay? Help me out. Angle A is equal to D. What else? Angle B is equal to E. Then what else? C is equal to F. Those are 3 things. What are the other 3? Give me this one. AB would have to equal what? DE. Let's do this one. AC, right? DF, and then the last one, BC and EF. How many things is that? That's 6 different things, isn't it? 6 different things we had to show. We had to show 3 angles equal to 3 angles and 3 corresponding segments equal to 3 corresponding segments. You follow me on that? But the nice thing is we don't have to show all 6 of those every single time. Okay, there are little shortcuts that they're going to give us. And it's going to be this. Watch. What if I knew that AB was equal to DE? Does that alone make these congruent triangles?
No.
No. What about that right there? Does that alone make them congruent triangles? No, because watch. If I gave you a stick or a pencil or something that was this length, I gave you another pencil that was a different length, a little bit longer, and I said, okay, Matt, here you go. Here's these 2 pencils. I'm going to make a triangle out of mine. You take the same exact 2 lengths, and you make a triangle out of yours, right? Are you going to get the same exact triangle? No, you're not, because I might have my angle going like this, and my third side would be real short, right? He might say, hey, I'm gonna have my 2 pencils going out like this at a real wide angle, and that third side is going to be a lot longer. There's no way those triangles would be congruent. Would you agree?
Yeah.
But what if I said this? Okay, I'll give you these 2 pencils plus I'll give you a third side. All right, so I've given you 3 pencils, let's say, right? They're all different lengths, let's say, and I made a triangle out of those. All right, messed it all up, gave him those 3 pencils, and I said, okay, you make a triangle out of those 3 lengths. Tell me something about his triangle and my triangle. Do you think he can make a triangle that looks different than my triangle?
No.
You couldn't. They'd have to be exactly the same, wouldn't they? All right, so if I give him 3 lengths, what that's going to do, it's going to make his triangle identical to my triangle. You get it? All right. Have I even said anything about the angles? No, I haven't. Because look, if I take this one and angle it out like that, what's going to happen to my third side? That's going to change length, isn't it? But if I have to keep the lengths the same, well, this angle is going to be the same as well, isn't it? And this angle is going to be the same, and so is this one. So there's no way I could get different triangles. So really, I don't have to show all 3 sides and all 3 angles. All I have to do is show what? No, what have I shown right here? Bang, bang, bang. It's not 2. It's what? All 3 sides. All 3 sides, okay? If I can show that 3 sides of this triangle, are you listening to what I'm saying? Pay attention. If I can show that 3 sides of this triangle equal 3 sides of this other triangle, then guess what must be true about my 2 triangles? They are going to be what? Congruent. That's right. All right, so triangle ABC. Now watch, if I go ABC, what am I going to have to call this one over here? DEF. Very good. All right. Now, we need a reason for that. And this reason is actually a postulate. Tell me something about a postulate compared to other things we've talked about. Yeah, so always accepted as fact. That's right. A postulate is just accepted. We don't have to prove it. We really can't prove it. It's just a rule that is true. All right, and you just have to believe it. All right, so this is actually a postulate. And watch, since I have 3 sides here, watch. I have one side, I got another side, and I got a third side. So what we do is we call this reason side, side, side. How about that? All right, now that's what we say. Now, on your paper, if you want to write it down as a reason, or if you know that these triangles are congruent right there, you can write SSS. But don't say SSS verbally. Say side, side, side. Does that make sense? All right, but you can write SSS. So if I say, why are these triangles congruent? Mr. I know. SSS. No, we don't say SSS. What do we say? Talk to me. Side, side, side. That's how we say it. Everybody got it?
Can we say side cubed?
You cannot say side cubed. All right, it's side, side, side. All right, so that's it for that. Pretty simple, see, isn't it? All right, just for that part, that's it.
Okay.
Okay, let's. I'll tell you what. We'll just keep the same. In the other class, I drew different triangles, but let's say if I can get rid of these little marks and get rid of these little marks, good. We'll get rid of these congruent triangle thingies. Okay, now watch this. Let's go back to the 3 pencils, okay? And I've got 3 pencils. Actually, let's say 2 pencils. I have 2 pencils, and I give you 2 pencils. But I want you to have the same exact triangle that I do. All right. So here's my stipulation. I'll say I'll give you this length of a pencil, and I'll give you this length of a pencil. But I'm not giving you a third one. But I'm going to do this. I'm going to tell you that the angle between those 2 pencils has to be exactly the same. All right. So if I give you one pencil and I give you another pencil, right? Pencil, pencil, and I said that angle between them. I don't know. Let's make a number up. Let's say 50 degrees. That looks like 60. Okay, let's say the angle between them is about 60 degrees. Right? And I told you, okay, here's a pencil, here's another pencil. The angle between them has to be exactly the same as mine. It's got to be 60 degrees. And I give you that information, and I say make a triangle out of it. Is there any way that you can manipulate it or change things around to get a different triangle than what my triangle looks like? No, there's not, because look, if I go the same angle here and here, and if I connect those 2 pencils together with a third side, it's going to be exactly the same. This is another postulate. That's right. And look what we have. We have a side, just like we had before, but now what did I introduce? An angle. You see it? So now this angle is equal to this angle, and then I got another side. So I'm going to call it side what? Angle. Oops, put a dash there. Side. So we call it side, angle, side. Notice where the angle is. They call it the included angle. All right, to be a little fancy, they say it's the included angle, or it's just the angle that's between those 2 equal sides. You got it? So it's the angle that's between there. It's not this side and some angle out here that's not in between. All right? It's the angle that's in between the 2 equal sides. This side's equal to this one's equal to this one, and the 2 angles in between, the included angles, are equal to each other. Then I can say that they're congruent because of side, angle, side. Again, there's no proof for it. This is a postulate. This is something that's accepted as fact. All right? And that's your reason. So if I gave you some information and I said, okay, why are these triangles congruent? What reason would you tell me? Side. No, come on. Side, angle, side. Right? And this is how you write it. SAS. You write it SAS, but you say it. We'll put quotes around it. How do you say it? Side, angle, side. Everybody got me? So you don't have to write it out. Write it out like this. Write it out SAS, but you say side, angle, side. Make sense? All right. We're going to use this a lot. This is going to be used a lot throughout this chapter. All right. And in other chapters, I think, as well. All right. Let's pause this and we'll take a look at a proof. I haven't even talked about a proof yet, have we? All right. So, but we're going to use this stuff. We're leading up to it. Okay. We're going to use this information right here to talk about proofs. All right, let's take a look at this thing. We're going to do a little proof. It's not really hard. It's pretty simple, I think. Here's the picture that they give you, but on a proof, they always tell you some stuff that's given, and they ask you to prove something. All right, so let's take a look at it. It says it's given that triangle QRS is isosceles. Remember what isosceles is? And with QR equaling SR. Alright? And then they tell you something else. Well, that's nice of them, isn't it? It says that RT bisects line segment RT, or actually I think they call it ray. I think it's a ray, let me see. They say it's a line segment, but anyway, it looks like a ray, doesn't it? Doesn't matter. Bisects QS, line segment QS at point QRT. Alright? And we want to prove that the triangles are congruent. So triangle QRT, it's supposed to be an R, a little weird looking, it's congruent to triangle SRT. Alright, there we go. So they're supposed to, yes, we've had that discussion earlier. Remember? Alright, so let's take a look. It says QRS is isosceles with QR equaling SR. So let's mark them. QR and SR are equal to each other. So I put a little tick mark on. Okay? It also says that RT bisects QS. RT, this thing right here, it bisects QS, which should mean what? If it bisects it, it splits it how? Okay, let's say into two equal parts. Okay, let's not say half. Let's say into two equal parts. There's a reason why I'm saying that. So if they're equal parts, what would be true about QT and TS? They would be equal to each other. You understand why I said that? Okay. That's all they tell you. That's all they tell you. All right? And you got to figure out why the triangles are congruent. Which triangles? QRT, that's this one over here on the left, and then SRT, this one over here on the right. We're trying to prove that these triangles are congruent. Well, I do have one side, don't I? See? This side is equal to this side, so that's one. And then I got a second one, QT and ST, right? That's a second side that are equal to each other. So really, what's all I need now? The other side, the RT, right? Would you agree? Now watch. Would you agree that RT is part of this triangle and RT is also part of this triangle? Are the lengths any different? No, they're exactly the same, aren't they? All right, because it's the same length. From R to T is the same here as it is to here. So watch, what could I put right here as far as just showing it on my picture? I could put three little tick marks. You see that? Now look what I have. I've got this side equals this side. That's one side. I got this side equals this side right here. That's two. And then I got this side equaling itself, don't I? All right? Because it's shared by both the triangles. Now, we have a reason for that. And this is kind of a nice reason. We're going to use this quite often, every once in a while. And this is always nice when we use it. And remember we skipped chapter 2, there's a few things in there. But one of the things is when you have something equal itself. So if I had A equals A, it's a property, and we call it the reflexive property. Reflexive. That just means if something equals itself. Okay, reflexive property. Write it down because we're going to use it quite often. So if something equals itself, there's a reason for that. And the reason is because the reflexive property. All right, reflexive is kind of like looking in a mirror, like reflection, right? So you see something that looks just like you, all right? So A equals A. Or in this situation, what would we say? RT equals RT. Does that make sense? All right, let's set up the proof. This is actually a fairly simple proof to do. So let me warn you, though. On some of these problems, it's going to say, write this as a flow proof, write it as a paragraph proof, or write it as a two-column proof. Are you listening to me? Every single time it asks you to do one of those, just write it as a two-column proof. Even if it says, write it as a flow proof or a paragraph proof. You follow me? Always write it as a two-column proof. Until we get going, maybe we'll do some a little bit later. Let's look what we're going to do. First thing they give us is that QR equals RS. So I'm going to write it right here. QR equals RS. What's my reason for that? It's given, right? They tell me. Now watch, you don't have to do this, and you won't see it in the book, but I kind of like to do this. What did I just show right here? I showed one of my sides, didn't I? So you don't have to do that, but I think it's a good idea to do this. So it's one of my sides. What else did they tell us? That QT, well actually they said that RT bisects, doesn't it? So we have to say that RT bisects QS. I'll just stop that right there. Why is that? That's also given. But if it bisects it, what does that mean then? It means that QT must equal ST. Would you agree? What's the reasoning? Because the definition of a bisector. The definition of a bisector says that if it bisects it, it splits it into two equal parts. That's my other side. I'm not going to go red because of time. So that's one of my other sides. What about the third side? RT equals what? RT, what's my reason? We said it already up there. It's the reflexive property. And now I can say that triangle QRT is congruent to triangle SRT. What's my reason now? Side, side, side. Whoa.